Started.
Recording has started.
Different operations here over the last few days. And today, there's going to be a quiz. You'll notice it's posted on Blackboard. So the first thing I want to do is I want to take you through how to access that quiz. So if you go into WITC here, go into Blackboard. There we go. And then once you're into Blackboard for this course, remember I said all the important stuff is going to be in course information. So that's exactly what you go to course information. You'll scroll down to week 1. For week 1, we've got the information from the last 3 days. We got the recorded lecture and the homework for each of the last 3 days. And now there's a quiz here listed as January 21st. Now I will still have the recorded lecture and homework for January 21st for today on there after class, but the quiz is out there right now. To access the quiz, if you click on the title here, not the link, you can click here and download the quiz if you want, but it's best if you click here to access it. And you'll see here, this tells you this quiz is worth 12 points. Here's a link to the quiz here. You can download it here as well. So if you click there, it'll download the quiz for you. When you're done with the quiz, if you're able to give it to me on campus, if you're at Rice Lake, you can do that on Monday. Or you can simply, once you've saved the quiz to your computer, you can complete it. And you can use right here, browse local files to find it off your computer. And you can upload it back up into Blackboard. So that's probably the easiest way to do it. You can either complete it electronically. You can download it like this, open it, and you can complete it electronically if you'd like to. Type in show as much of your work as you can typing. Show your answers, and then upload it back in so you can do it all electronically. You don't have to have a printer or a scanner to do that. Or if you would prefer to print it off, complete it with pens on paper and pencil, and then scan it back in. Make sure that if you're using a pencil or a pen, that you write dark enough that once you scan it back in, it's readable. It happens to me. I have a couple of classes that have been in this virtual format for years. It happens every test. Somebody does it in pencil and they press really soft and they scan it back in, and I cannot read anything that they wrote on their test. So make sure you write it dark enough so once you've scanned it in, take a look at it, make sure it's legible, and then you go back to Blackboard here and you browse and you upload it back in. Or if you don't have a scanner, you can use your cell phone or whatever to take a picture of it and submit it that way as well. You can submit it as a local file that way as well. That way they all come to me in Blackboard and I can grade them, or you hand them to me personally in class and I can grade them. Other ways of sending them to me just get to be too difficult to figure out who comes from where. If you have any difficulty getting them uploaded with Blackboard, either let me know or talk to the tutors or the library at your campus, and they will help you do that as well. Okay, so enough of that. You guys know where the quiz is. You know how to get to it. So let's hit our new material for today. So our lecture will be a little bit short today because I want to give you some time to make sure you have. Normally we would take the quiz in class, which would take about 10 or 15 minutes. You're going to get that at time off of class so that you can go take it on your own and get it submitted. The quiz must be submitted at the start of class on Monday, so you have the whole weekend to finish it if you need to. The first 4 problems on the quiz, I believe it's the first 4. I don't remember if it's the first 4 or the first 6. they say no calculator. Well, that's obviously, since you're working on it at home, I can't look to see if you didn't use a calculator. And really, it's not, no calculator isn't really my purpose there anyway. My purpose is I want to make sure that you actually know how to do the calculation. So what I really mean on those is show the calculation. If you are writing it out if you're printing it and writing on it, that's fairly easy to show. Just, do your calculation like you normally would. If you're going to try to do it electronically on the computer and type it in, you just have to tell me you're going to borrow or carry or whatever, so that I know that you knew how the calculation worked. Okay, so our next step, we've looked at the basic numbers and the rules of numbers and number theory. We've looked at working with basic whole numbers. And now we're going to, the recording is going, good. Okay. And now we looked at integers, negative numbers yesterday. Today we want to take the next step. What happens when we have numbers that look like this, or problems that look like this? (19 minus 3 times 5 plus 7). When we look at that, there are actually a few different ways we could interpret that problem. Somebody might look at it and say, well, we're going to work left to right because that's the direction we read. That would make perfect sense. You would do 19 minus 3 is 16. 16 times 5 is 80. 80 plus 7 is 87. Makes perfect sense, but guess what? It's wrong. Others might look at it and say, well, in our other operations, or at least addition, subtraction, and multiplication, we start on the right and work our way back to the left. Maybe we should do that. Well, again, that's going to give you a different answer, and it would be wrong. We said there are different ways of doing math, but there's only one correct answer. So we need to find some way that when everybody does this problem, they all get the same answer. And so to make sure that happens, they've defined something called the order of operations. Now, most people think that the order of operations is a list of steps. You go step 1, 2, 3, 4, 5. It's not really just a list of steps. What it really is levels of priority. And so the things, the first levels are higher priority. If there's multiple things that need to be done, we do the things of high priority first. However, there may be times where we have to jump back up. We have to finish something up in a low priority and jump back up to a higher priority. So it's not really just steps. We're not just going right down the line. We have to sometimes jump up and down in those levels of priority, depending on what's presented in the problem. So the highest priority is something called enclosing symbols. Now, many of us, this is just parentheses. And that is the most common enclosing symbol. It's one of our enclosing symbols. But there are other enclosing symbols that we will encounter throughout class today that are not parentheses that also have to be considered in order of operation. Second is exponents. Looked briefly yesterday at exponents. Remember, this includes powers and roots. Remember, that's an inverse pair. Powers is going forward, roots is going backwards. Our third level of priority is to multiply and divide. Again, an inverse pair. Multiplication and division always go together. One's forward, one's reverse. And then our lowest priority only gets done if there's nothing else to do, or if we have to get it done in order to get it out of the way for something of higher priority, is to add and subtract. Now we've left some things out here. This is the basic order of operations. There are things like exponentials and logarithms, another one of those inverse pairs of operations that we mentioned. That's beyond the scope of this class, so we didn't include them here. It's beyond the scope of many classes, so it's not included in the order of operations, in the basic order of operations in most cases. There's also trig functions, sine, cosine, tangent, and their inverses. Those are typically, again, included in a more rigorous order of operations, but since they're not part of basic classes, they're not in the basic order of operations. So what do we do here? Let's take a look at our problem here, our example, and apply this order of operations to it. We don't have any enclosing symbols, so we can ignore that. We don't have any powers or roots, so we can ignore exponents. Multiplication and division. We do have a multiplication here. So that's the highest priority item in this problem. Multiplication is 3 times 5. So we're going to take that 3 times 5 and we're going to replace it with, well, 3 times 5 is 15. The rest of the problem stays exactly the same. Well, now there's no more multiplication and division. Don't have to worry about that. There is addition and subtraction. There's one of each. Well, addition and subtraction happen at the same time. And when there's more than one item at the same level, then we do go left to right. So here we're going to do the subtraction first, because as we go left to right, that's the one we come into first. So we have 19 minus 15, which equals 4. So replace the 19 minus 15 with 4. The rest of the problem stays exactly like it was. And now all that's left is to add 4 plus 7, which is 11. So that original problem, 19 minus 3 times 5 plus 7, is 11. So let's take a look at something just a little bit more complicated. This one's a little bit more complicated. Actually, it's quite a bit more complicated, but it has something from each of our levels of priority on it. So as we go through here, enclosing symbols is our highest priority. We have a couple of different parentheses here. Remember, if we have more than one item on the same level, we work left to right. So this set of parentheses here is the first one working left to right. So we're going to start inside that green box, inside that set of parentheses. Well, inside there, we still have to apply the order of operations. There are no other enclosing symbols here, so we go to exponents. Well, we have square roots and powers here. So we go left to right. Going left to right, the first one is the square root of 16, which is 4. So I replace the square root of 16 with 4. And the rest of the problem stays the same. Now there's something here. That square root symbol can do a couple of different things. It does represent square root, but it can also represent multiplication. In this case it does, because there's a number written in front of it with no operation there that is implying multiplication. So when I take out the square root symbol, when I do the square root, I have to put that multiplication in there so it doesn't get lost. I got the plus 5 times 2 cubed minus 11. Again, we rewrite the rest of the problem exactly as it was. So we're still looking inside this set of parentheses here. We have another exponent. This one's a power, 2 to the power of 3, which is 8. So I replace the 2 to the power of 3 with 8. And the rest of the problem stays exactly as it was. Now I'm still inside that parentheses, still applying the order of operations in there. No more exponents, so we're at multiplication and division. We go left to right. Going left to right, the 3 times 4 is first. 3 times 4 is 12, so replace it with the 12. The rest of the problem stays exactly like it was. Still inside that set of parentheses, there's another multiplication. 5 times 8, which is 40. So replace the 5 times 8 with 40. And the rest of the problem stays again exactly as it was. Still inside that parentheses. So you might wonder, well, how long do we have to be inside that parentheses? Until we reduce it down to a single number. Every enclosing symbol works that way. We have to stay within the enclosing symbol till we reduce the enclosed area to a single number. So in here, all that's left now is addition and subtraction. They happen at the same level, so we go left to right. 19 minus 12 is 7, so replace the 19 minus 12 with 7. And the rest of the problem, again, stays the same. We have the 7 plus 40, which is 47. So replace that with 47. And again, the rest of the problem stays the same. And finally, 47 minus 11 is all that's left inside the parentheses. That gives us 36. So we replace the 47 minus 11 with 36. And the rest of the problem stays the same. Now we said we had to stay inside that parentheses to reduce it to a single number. It's reduced to a single number. So now what do? Well, once we've reduced that to a single number within our enclosing symbol, the symbol isn't enclosing anything anymore. So the parentheses are not needed as an enclosing symbol anymore because there's only a single number there. But parentheses, just like the root that we saw, have other functions it can do. So we can take the parentheses out for as far as an enclosing symbol. We don't need them for that, but we have to make sure they're not doing any of those other functions. One of those other functions is to signify multiplication. It's doing that here. There's a 2 in front of the parentheses with no operation. That indicates 2 times whatever's in the parentheses. So when I remove the parentheses here, I have to make sure to put in that multiplication symbol so that we don't lose that. Because the parentheses were also symbolizing multiplication there. Now, we've been down through the levels of priority: enclosing symbols, exponents, multiplication and division, addition, subtraction. But the problem isn't done, so we jump back up to the top again. Are there any other enclosing symbols? And there are. This parentheses over here. In that parentheses, again, order of operations applies. No enclosing symbols, no exponents. Do have multiplication and division. 3 times 5 is 15. So replace the 3 times 5 with 15, and the rest of the problem stays exactly as it was. Now we're still working inside that parentheses. All that's left is to subtract 19 minus 15, which is 4. Now typically, just to save a little bit of writing, when I get that enclosing symbol down to a single number, rather than writing it out with the parentheses in and then writing it again with the parentheses out, I just take the parentheses out. But again, like I did up here, I have to double check to make sure the parentheses wasn't doing anything else. This parentheses was not symbolizing multiplication because there's a subtraction in front of it. and there's nothing behind it. So when I take out that set of parentheses, I don't have to put in multiplication, and there's nothing else that parentheses was doing there. So once I've got it down to that single number, which is the 4, I can remove the parentheses. Now we go back up the ladder again. No more enclosing symbols. No more exponents. There is multiplication and division. 2 times 36, 72. Everything else stays the same. All that's left is addition and subtraction. We're going to go left to right. 9 plus 72 is 81. 81 minus 4 is 77. So like I said, we should think of our order of operations not as a set of steps, but as levels of priority. So we look at what we got, we see what's the highest priority out of what we are able to work on at that point. We might have something like 14 plus 3 times 27 minus something like that. Now this one has 2 sets of parentheses in it as well, but one's inside the other. When we apply our order of operations, we still, if there's more than one thing at the same level, we still go left to right. So the first enclosing symbol, or first parentheses we run into, is right here. We need to find its other end. Well, this one's facing the wrong way. That can't be its other end. This one's facing the right way, but that goes to this one here. So the other end of that is down here. So we're going to start our work inside that set of parentheses, inside the green box in this problem as it's written. Well, order of operations inside there still applies. Inside that set of parentheses, we look for more enclosing symbols, and we have them right here. There's another set of parentheses. So we have to focus on that inside set of parentheses, the blue box there. In there, order of operations still applies. No more enclosing symbols. We do have an exponent, the square root of 25. So we do the square root of 25 as 5. Now again, when we take out the radical, we have to make sure it wasn't doing anything else. And it was also signifying multiplication there. So we're going to have to remember to put in that multiplication. So working inside that light blue box, inside there we have multiplication is our highest priority. 3 times 5 is 15. Yes, I realize that these get to be a lot of writing, but by rewriting them, you save a lot of mistakes. Where I see most people make their mistakes is if they try to only rewrite part of the problem, and they end up missing something or forgetting something. So now inside that set of parentheses, there's only one thing left to do. 17 minus 15 is 2. We look outside the parentheses, it's not signifying multiplication because there's operations on both sides of it. So we can just take out the parentheses and replace it with the 2. Now that inner set of parentheses is complete, we can go back out to the larger set of parentheses here. In there are no other enclosing symbols. There are no exponents. So we're down to multiplication and division. There's one of each here, so we have to go left to right. 8 times 6 gets replaced with 48. Still working inside there. 48 divided by 12 is 4, so replace that with 4. Now all that's left is subtraction, so we'll go left to right. 27 minus 2 is 25. We replace that with 25. And the last piece we have to do there is the subtracting 25 minus 4, which is 21. We've reduced that to a single number. So that means I can take out the parentheses, but again, I have to check to make sure it wasn't doing anything else. And here it was symbolizing multiplication. So I have to make sure I put in that multiplication. So it's 14 plus 3 times 21. Now we have highest priority here is the multiplication. 3 times 21 is 63. What we have left is addition, so we're going to go left to right. 14 plus 63 is 77. And 77, come on. 77 plus 5 is 82. Well, those are two of the more standard type order of operation problems. Let's take a look at something a little bit different. Let's look at something like this. Here in a problem like this line across here we have to define before we can do anything else. Now most people will jump in and say, well, it means division. And it does. Division is part of it. It's called a fraction bar. And along with division, it is also an enclosing symbol. It separates the top of the problem from the bottom of the problem. So that means it's telling us we have to do each of those pieces separately and then divide. Well, to do the top here, I'm going to have to write it off to the side, so I'll put it over here. And we still have to apply our order of operations there. There's no other enclosing symbols. There are no exponents. So we'll do our multiplication and division. We're going to go left to right. 7 times 9 is 63. Next is the 30 divided by 6, which is 5. And now we just have the addition. 63 plus 5 is 68. So the top of that reduces down to 68. Now we have to complete everything on bottom. On bottom here, we have no other enclosing symbols. We do have an exponent, square root of 4, which is 2. Now we have multiplication and division. We'll go left to right. 5 times 3 is 15. Then we've got the 22 divided by 2, which is 11. And all that's left is a subtraction. 15 minus 11 is 4. So the bottom of that reduces to 4. So we have, now we've done the top and the bottom separately. Now we can divide. 68 divided by 4 is 17. That gives us 17. Another type of problem. Might look like this. We've got 11 minus 2, then that's the square root of 1 plus 7 times 3 squared. So we see that square root symbol, that root. Well, here it has we've said it could do other things other than just the square root. It's doing a couple other things. One is it is signifying multiplication. That 2 is multiplying whatever the result of that square root is. The second thing it is it is an enclosing symbol. It's separating this part of the problem from the rest, telling us that we have to start inside the radical, inside the square root. Well, in there are no other enclosing symbols. There is an exponent, though, the 3 squared, so we're going to do that. 3 squared is 9, so I'll replace that with 9. Everything else stays the same. Well, we have multiplication inside the root. 7 times 9 is 63. So replace that with 63. Again, everything else stays the same. Still inside the root, 1 plus 63 is 64. Now, and everything else, of course, stays the same. Now, I've reduced what's inside the enclosing symbol to a single number. Just like with parentheses, I can take out the parentheses. The difference here is, of course, there's something that has to be done when I remove the square root symbol. I have to do a calculation. The square root of 8, or square root of 64, is 8. And remember we said that that's also signifying multiplication. So when I take out the square root symbol, I have to put in the multiplication. This is 11 minus 2 times 8. Now we're done with the root, done with the enclosing symbol. Back in the bigger problem, highest priority is the multiplication. 2 times 8 is 16. And we have 11 minus 16 gives us a negative 5. So that's our result there, is a negative 5. Any questions? Okay, well, that's all of our material today. Like I said, I wanted to make sure I gave you some time to deal with the quiz and, the normal little bit of homework time. Your homework is out of the book, page 13 through 14, 1 through 41, the odds. Again, I realize there's 21 problems there. If the first few seem easy, skip ahead to the more difficult ones. I don't collect them and grade them, so please don't just skip it completely, but I'm not going to make you do busy work on stuff you already know. If the easy ones are too easy, jump up to the more difficult ones. If you struggle with those, slide back down to some of the easier ones and practice. Anybody have any questions? Okay, well, with that then, you'll have the rest of the time. If you'd like to start on the homework, I'll be on the network here to answer any questions and help you out.